Hello everyone, my name is Shashank. I'm from Honda section, SPCU College Honda section from ECE department. Today I'm going to be talking about exponential growth and decay. This presentation begins with an overview of exponential growth and decay. We'll be exploring the analysis of applications in various fields and exploring the underlying mathematical principles. The presentation concludes with key insights, takeaways on exponential growth and decay. Introduction to exponential growth and decay. Exponential growth. The exponential growth occurs when a quantity increases at a rate proportional to its current value. Exponential decay, on the other hand, occurs when a quantity decreases at a rate proportional to its current value. The formula for exponential growth is y is equals to a into e to the power kt. Here y implies final amount, A implies initial amount, K is growth rate, T is time. The interpretation is the model represents the growth of quantity as a function of time. Applications of exponential growth. The population growth, firstly, where India is the largest populated country as of now. So it's calculated. How do we calculate that? It is the increase in the number of individuals in a population over time. And investment growth, that is, you invest the amount which you invest in banks or loans or it increases over a period of time. That is compound interest. The spread of information, the rapid dissemination of information through social media and other channels. Compound interest and exponential growth. Compound interest. Interest calculated on the principal amount and any occurred interest. Growth. The balance increases exponentially over time due to the compounding effect. Formula for compound interest is A is equals to P into 1 plus 1 by n the whole to the power n into t. Doubling time and half-life. The time it takes for a quantity to double in size. Half-life. The time it takes for a quantity to reduce to half its original size. Exponential decay model. Formula for exponential decay is y is equals to a into t into e to the power minus k. Variables. Y is the final amount. A is the initial amount. K is the decay rate and T is the time. The interpretation for this exponential model is the model represents the decrease of a quantity as a function of time. Applications of exponential decay. Radioactive decay. The decay of radioactive isotopes over time. Drug metabolism. The breakdown of a drug in the body over time. Depreciation. The decline in the value of an asset over time. Newton's law of cooling. The rate of cooling of an object is proportional to the temperature difference between the object and its surroundings. The application for Newton's law of cooling is used to predict the temperature of an object as it cools down. The formula for Newton's law of cooling is capital T into small t is equals to T into S plus T naught plus minus Ts the whole to the power E into the power minus t. So, what is the difference between exponential growth and decay? You might be wondering. While both involve exponential functions, exponential growth refers to quantity increasing over time, while exponential decay refers to when the quantity decreases over time. I give an example of stocks here where it increases gradually over time, but sometimes it also goes down where we experience losses and everything. Next, exponential growth model. So this is another formula for exponential growth model. Y dash is equals to y k into y naught into k to the power kt to the power kt, and which is equals to ky. This is the graph for exponential growth. As you can see, the green line which increases drastically when it reaches over 7 and 8 in the xy line. Then we have exponential decay model where f of x is equals to ab into power x. F of x is equals to a into 1 minus r to the power whole to the power x. P is equals to p naught into e to the power minus kt. Here's the exponential decay model where the graph line reduces drastically by the time it reaches 0. The conclusions and key takeaways are: exponential growth model, a quantity increases at a rate proportional to its current value, and exponential decay, on the other hand, a quantity decreases at a rate proportional to its current value. That's all, guys. Thanks for watching. Please be sure to like and don't forget to subscribe. Thank you.